In this session tunaenda kudiscuss kuhusu Kohlrausch's law of independent migration of ions. Kohlrausch's law of independent migration of ions. The law states that the molar conductivity of electrolyte at infinite dilution is equal to the sum of the molar conductivities at infinite dilution of its ions, that means cation and anion. For we can apply this law for an electrolyte. Molar conductivity of at infinite dilution of electrolyte is equal to molar conductivity at infinite dilution of cation plus molar conductivity at infinite dilution of anion. So manake ni kwamba molar conductivity at infinite dilution is equal to molar conductivity at infinite dilution cation plus molar conductivity at infinite dilution anion. Hiyo ndio Kohlrausch's law. Hiyo ndio Kohlrausch's law. Sasa tuone for any electrolyte ambayo we can take an example. For example, hapo tumechukua it's weak acetic acid. For weak acetic acid we'll have CH3COOH, then equilibrium CH3COO dash plus hydrogen yule pale. From there, Kohlrausch's law, molar conductivity at infinite dilution of acetic acid, molar conductivity at infinite dilution of ethanoate ion plus molar conductivity at infinite dilution of hydrogen ion. Hiyo ndivyo ambavyo Kohlrausch's law inakuwa inaenda. Note that the total current that pass through the solution of electrolyte is carried by cations and anion. Total current is carried by cation and anions, cations and anions. Therefore, the fraction of total current carried by cations or anions is in the solution of electrolyte is called transport number. Fraction of total charge carried by anion or cations is known as transport number. Application of Kohlrausch's law for independent migration of ions. Kwanza ni determination of molar conductivity for weak electrolyte. Molar conductivity for weak electrolyte at infinite dilution. Lakini pili ni determination of degree of dissociation. Degree of dissociation or ionization of weak electrolyte yani acid na bases. Tatu ni determination of ionization constant of weak acid and bases. Ionization constant. Na nne determination of solubility of spongily soluble salts. Tano, determination of solubility product of spongily soluble substances. Actually, we will not go into deep and discuss these applications of Kohlrausch's law for our level, but tutaenda kuona calculations tu ambazo tutakuwa tunatumia Kohlrausch's law. What you need to understand here is simply the applications. From there, we have the factors affecting electrolytic conductance. Factors affecting electrolytic conductance of any solution. The first factor is the nature of electrolyte, whether it's weak or it's strong electrolyte. The conductivity of an electrolyte depends upon the number of ions present in the solution. Therefore, the greater the number of ions in the solution, the greater is the conductance or conductivity. The number of ions produced by an electrolyte depends on its nature. Number of ions produced by an electrolyte depends on its nature. So the strong electrolyte dissociates almost completely into ions in solution. and they dissociate almost completely into ions in the solution, and therefore their solution have high conductivity or have high conductance. On the other hand, weak electrolyte dissociate partially or only small extent and give less number of ions. Therefore, the solution of weak electrolyte have low conductivity. It have low conductivity. Number 2 is the concentration of the solution. Concentration of the solution. The molar conductivity of electrolytic solution varies with the concentration of electrolyte. Molar conductivity of electrolytic solution varies with concentration of electrolyte. In general, the molar conductivity or conductance of electrolyte increases with the decrease in concentration or increase with the dilution. Conductivity of strong electrolyte as well as weak electrolytes increases with the decrease in concentration. Increases with the decrease in concentration or increase in dilution. The variation is, however, different for strong and weak electrolyte. Weak and strong electrolyte is not different. For weak electrolyte, the variation of conductance with dilution on explained on the basis of number of ions in solution. For weak electrolyte, naona tuta explain kwa kutumia number of ions in the solution. The number of ions for function by the electrolyte in the solution depends upon the degree of ionization or dissociation with dilution. With increased dilution, the degree of dissociation increases, and as the result, with increase in dilution, degree of dissociation increases, and as the result, the conductance or conductivity increases also. For strong electrolyte, kwa electrolyte ambazo ni strong, there is no increase in number of ions. No increase in number of ions with dilution because strong electrolyte are completely ionized. They are completely ionized. In a solution, at all concentrations, however, in a concentrated solution of strong electrolyte, there is a strong force of attraction between the ions of opposite charges called the interionic force. Katika strong electrolyte, kuna strong interionic force katika concentrated solution. Due to these interionic forces, the conductivity, the conducting ability of ions is less in a concentrated solution than strong electrolyte. So with the dilution, tunavozidi kudilute solution, with the dilution, the ions become far apart from one another and the interionic force decrease. As the result, molar conductivity increases. Molar conductivity increases with the dilution. Molar conductivity inakuwa inaongezeka kwa kadri dilution inavyokuwa inazidi kuongezeka. Molar conductivity increases with the dilution. When the concentration becomes very low, the interionic attraction becomes negligible, and the molar conductance approaches the limiting value called the conductance at infinity dilution. Conductance at infinity dilution. That is for strong electrolyte. The third factor is temperature. Now, the conductivity of electrolyte depends upon the temperature. With the increase in temperature, the conductivity of electrolyte increases. Conductivity ya electrolyte inaongezeka na temperature. Kwa hiyo tuna factors tatu ambazo zina affect conductivity. Now to discuss kuhusu ionic migration. Unaweza sema kwamba tunasoma tena ionic migration wakati tusha discuss. This part is very important. Kuna concept ambazo tutadiscuss hatujaziongelea kule nyuma. Migration or mobility of ions is defined as the movement of ions due to the externally applied electric field. Movement of ions due to externally applied electric field. In the conductance cell or the anode, the excess of positive ions build up of the positive charges at the cathode. So here is at the anode, the excess of positive ions build up of positive charge, and at the cathode, hii hapa ni at the anode. At the cathode, excess of negative ions builds up negative charge. Kwa hiyo cathode inakuwa na negative charge, anode na positive charge. Build up ionic charge is released by the ion transport. Positive ions move from anode to cathode and vice versa. Kwa hiyo finally kitu kama hicho kitapelekea nini? The transport number, also called transference, is defined as the fraction of total current carried by the ions of specific type, either positive or negative ions. Each mole of current passed corresponds to 1 mole of electrochemical charge at each electrode. Therefore, the amount of ions transported in the electrolyte also equals to 1 mole. Amount of ions transported to electrode. The amount of ions transported in the electrolyte also equal to 1 mole. Now, why do ions move at different rates, and why do they have different molar conductivity? Ions, sasa hapa hatuzungumzii solution, nazungumzia ion. Ions in a different molar conductivity. Why do they move at different rates, and why do they have different molar conductivity? Labda kwa nini sodium ita move with different velocities compared to potassium or calcium? As discussed earlier, conductance of an electrolyte in solution is due to motion of ions through a solution as the result of applied potential or applied electric field. Current density is the function of rate of constituent ions to carry their charge. Through the solution. Hiyo nasema ni current density. This rate depends upon the density, concentrations of ions, and the valence charge of ions, as well as their speed. So, molar conductivity at infinite dilution indicates how a particular ion contributes to the conductivity of a solution. Molar conductivity at infinite dilution inaonyesha ni kwa kiwango gani hiyo ion ina contribute to the conductivity of a solution. So it measures how little charge can move through the solution. Inaonyesha to how much extent hii charge inaweza ka move kwenye solution. For this reason, we would expect molar conductivity at infinite dilution to be proportional to the charge on ion. This means that highly charged ions carry more charge through the solution than lower charged ions, and hence have a higher value of molar conductivity at infinite dilution. This is actually the case with exception to hydrogen and hydroxide, which have abnormally large value of molar conductivity at infinite dilution. For example, sasa tuchukue example ya few ions na tuone. Tunazungumza molar conductivity for infinite dilution ya sulfate ions, covalent ions na bromine ions. The molar conductivity of the sulfate ions at infinite dilution imeonekana kuwa ni double. It's almost twice the molar conductivity of infinite dilution of chlorine and bromine. Kwa nini charge yao ni -2, yao -1 na yao -1? However, there are some obvious variations from this behavior. Na kumbuka tulisema hydrogen na hydroxyl haziingii kwenye hii property. Hii property ina involve only other ions. So the charge cannot be only factor determining the conductivity. Sio charge peke yake. Charge is one among the factor, but it's not only charge. But it is also dependent upon how little the ion can move through the solution towards electrode. Ni kwa kiwango gani ion itamove kwa urahisi, itamove kwenda kwenye electrode. The faster the movement of ions, the greater the movement of charge through the solution. Then the higher the value of conductivity is. So the ease at which an ion moves through the solution is therefore determined by the size. By the size. Ion ina size gani? Inspection for conductivity of cations show that conductivity increases as we move down the periodic table. Conductivity increases as we move down the periodic table. For example, for some metals in the periodic table, the conductivity, tukianza na group 1, lithium ni 37.8, sodium ni 50.1, potassium ni 73.5. Group 2, magnesium ni 106.2, calcium ni 119.0. Radius of ions decreases as we go down the periodic table. Radius of ions, radius of ion decreases as we go down. Probably might be yes, because this is different from the radius of atoms. Radius of atoms and radius of ions in vitu tofauti. But this is contrary to what we expect about the size of ions down the periodic table. Now, learn by heart, ions in the solution are surrounded by a solvation shell of tightly bound water molecule. So when an ion moves through the solution, it moves with this solvation shell. Therefore, the radius to be considered must be an effective radius, not a radius of the naked ion. Effective radius is equal to radius of ion ya naked plus its solvation sphere. Hii ndio kitu inasababisha a radius of ions iwe kubwa as you are moving down the group, wakati radius of ions iwe ndogo as you are moving down the group. Remember, tunavyokuwa tuna group 1 elements such as lithium or sodium or even potassium, they are small. Sodium is smaller inside than potassium. Unaona, sodium being smaller inside than potassium, it will have large effective nuclear charge. Large effective nuclear charge. Au kwa lugha nyingine tungesema kwa sodium kwa sababu yenyewe ina nani kubwa, sodium tungeweza kusema inakuwa ina high electronegativity. So sodium ikikaa hapa itavuta water wengi, watakuwa water wengi. Wakishakuwa water wengi, wataongeza the solvation radius, tajikuta radius yake ni kubwa as compared to lower element ambazo hazitaweza kuvuta water nyingi. So radius yake itakuwa ndogo. Lower element, they will not be able to attract a lot of water. It's because of the low electronegativity of these elements as we are moving down the groups. Note that the smaller the radius of ion, the stronger the solvation sphere around the ion. So the larger the effective radius of the ion. This explains why the conductivity of lithium is lower than the conductivity of potassium. Lithium has small naked radius, so it has much stronger solvation sphere, leading to large effective radius compared to potassium. Similarly, similar effect may be seen among the anions, but it is not so pronounced as for cations. The reason ni kwa sababu anion hazina uwezo mkubwa wa kuattract water kwa sababu zina excess electron. The reason is that the naked radius of an ion is usually much larger than that of cation, making anions weakly solvated, and hence size of effective radius is not so important. Thank you. Let's conclude here. Nikijacho ta solve maswali ya conductivity tukiwa tunamaliza topic yetu ya electrochemistry.